So let's go ahead and talk about this rational function. First, we're supposed to discuss the domain. You know the domain of the function is the allowable x values, and we don't want to have division by 0. So we make sure the 6x minus 18 does not equal 0. So that means the 6x must not equal 18, and that means x must not equal 3. So to describe the domain of the function, we want all the real numbers except 3. In interval notation, we would say from negative infinity up to the 3, union 3 to infinity. And because we have the denominator going to 0 when x is 3, that gives us a vertical asymptote at x equals 3. If the numerator went to 0 also when x is 3, then we'd have a hole in the graph. But there are no holes in the graph because the numerator does not go to 0 at the same time as the denominator. We can say even more about that vertical asymptote though. We can look at our graphing calculator and see what the graph looks like. So if you take a look at your graphing calculator, you'll see the graph approaching the vertical asymptote, going up on the right-hand side of the vertical asymptote and going down on the left-hand side. So we describe this going up on the right. We describe that going up to the right of the vertical asymptote by saying, let's see, let's write it in black. As x approaches 3, and then we put a little plus sign to mean 3 from the right, or numbers that are a little bit bigger than 3. So as x is approaching 3 from the right, with numbers a little bit bigger than x is 3, then the y values, f of x, go to positive infinity. And then we can talk about the function approaching the vertical asymptote on the left side of the vertical asymptote by saying, as x approaches 3, and then put a little minus sign, and that means we're approaching 3 from the left, or numbers that are a little bit smaller than 3. When x is a little bit smaller than 3, the y values, or the f of x, are approaching negative infinity. Okay, so they're getting to be big negative numbers down here. We can't actually plot negative infinity, but if we could, we'd have our graph approaching y values of negative infinity. Let's talk about the horizontal asymptote. To find the horizontal asymptote, we take our function and we divide by the highest degree of x in the denominator. So that would be x. So I divide each term by x. That's the same as multiplying by 1 over x in the numerator and denominator. So that gives me x over x, 6x over x, minus 18 over x. And that all reduces, so we get 1 over 6 minus 18 over x. So we made a complex fraction because now we can see what's happening as x gets really big. So as x gets really big, this 18 over x goes to 0. So the 18 over x goes to 0 as x goes to infinity or negative infinity. So as x is real big, like a million, then you have 18 over a million, which is real little. And that means that y is approximately 1/6 when the x's are really big. So y equals 1/6 is the horizontal asymptote. So we have this imaginary line at y equals 1/6. So actually I should draw my curve here. Approaching y equals 1/6 on. So that would be above the x-axis a little bit, 1/6 above the x-axis. So there's a horizontal asymptote, y equals 1/6, and a vertical asymptote at x equals 3. If we want, we can describe the horizontal asymptote also. You could say that f of x approaches 1/6 as x goes to infinity. So as x goes to infinity, f of x approaches 1/6. The y values are getting close to 1/6 as the x values are getting really big, or really small for that matter.